category 2 is going to cover a lot of topics as well. Rate of change and slope. We're going to graph linear equations. We're going to look at the key features like the x and y intercept, the slope, things like that. We're going to graph linear inequalities. We're going to do transformations. That's where we move the graph around. We're going to look at systems and linear regressions. All right, so here we go. Okay, so I've got 3 situations here. We're going to find the rate of change or the slope. When you're given a table, there's lots of different ways. One is we can use that formula. The slope equals, hold on, let me get my pen, y2 minus y1 over x2 minus x1. We can use that. Oops, 1. You can also just use your regression. You could go into stat, go into edit. Let me zoom in on this because I know it's probably a little hard to see. I could go over here and I could put my table into here. So -2. For me, this is the way I like to do it. I find that I don't make mistakes when I do it this way. It's the easiest. It takes a little bit more time, but at least I don't mess up. Okay, so rate of change is a constant rate of change. It's linear. So I go to stat, calculate, and I do number 4, a linear regression. I want to know what is the slope? What is the rate of change? What is the m? Remember, m is in the place of the a, so a is 3. So that would mean my slope right here is 3. Okay. If I plugged it in, I would get that same answer. When you're given a graph and you have to look at it and come up with the slope, well, remember we've got rise over run. Okay, so this would be going down. We read from the left to the right. This is going down, so this is a negative slope. 1, 2, 3, 4, 5. So I go down 5 and over 1, 2, 3, 4, 5 and over 5. So rise over run. I rose up -5 or fall and crawl, and I ran over 5. -5 over 5 is the same thing as -1. I do want to simplify that. Other ones are ones where you just look at it and you're like, oh, well, what's the slope? Remember, this is in point slope form. Y minus y1 equals the slope times x minus x1. M is the slope, so the slope is 1/3. So when you're finding the slope, there's lots of different ways we can do it. You're going to see that as you go to do your test on this. All right, the other thing, let me pull up the next thing. Graphing equations. So y equals 3x plus 2. If I were going to graph that, I would hope most of you would just plug it into your calculator, 3x plus 2, or into Desmos. Hit graph. On Desmos, it'll graph it automatically for you. You're just going to look on it. You're going to graph it. If you have to graph some points, you can do second table. You can pick up your points. And there you go there if you're going to graph it. On Desmos, I believe we can do, you know what, I actually don't know that now that I'm thinking, but I think that's right. On Desmos, you can actually just plug that right in and it will graph it for you. I would put it into Desmos. Sorry, I had a company come over. I would put it into Desmos and graph it, and I could see it that way. If I didn't put it into Desmos, I would move the x, divide the y. So I would move the x. I'm just going to work this one super quick. And then I would have -4x plus 10. I would divide by the y, which is 3, and get y equals -4 over 3x plus 10 over 3. Okay, move the x, divide the y, put it in my graphing calculator, and I would graph it. All right, the next thing we had was our key features. So let me draw. All right, so this is our x-axis, this is our y. Key features. This is the y-intercept, and where I cross the x-axis, this is the x-intercept. Now, x-intercept is also known as the zeros, and we also call it the solution. Sometimes we call it the roots, but you won't hear roots as much as you'll hear x-intercept and zeros. Or what's the solution? What's the solution to this equation? And it would be, what is the x-intercept right there? All right, let's see, graph linear inequalities. So when we want to graph an inequality on Desmos, I'm just going to do one here. If I were to put that into Desmos, it would graph it for me. On my calculator that I like to use, I would have to graph it, and so I'd put it in, and then it would look something like this. That would be the equation. This right here is y equals 3x plus 2. But I need to do greater than or equal to. Remember, when it has the line underneath it, that means my line is solid. When it doesn't, when it's just the greater than, I have a dashed line or a dotted line, as some people call it. This particular one is a solid line. It's greater than. What are values bigger than 2? Well, 3, 4, 5. So when I shade, this would be shaded up. On Desmos, it will shade for you and help you know what you're finding there. Areas or points that are in the shaded area, those are part of my solution. Rather than just having one solution or one answer, this has a whole bunch. Okay, anything on the line would be part of my solution. A typical question with this would be, I'll give you A and I'll give you B. Which one is part of my solution? Well, B, because it's in the shaded region. All right, the next one is, sorry, my phone just killed, transformations. Okay, so we have f of x equals x squared, and I want to know if g of x is 3f of x. Okay, what is the transformation? Okay, I'm going to pull out Desmos for this because I want to show you on Desmos. Okay, so on this, let me zoom in just a little bit, and then also let me zoom in here. I put in f of x equals x squared, g of x equals 3f of x. When you put it into Desmos, it will do it for you. So the blue, I don't know if you can tell that that's blue. Blue's on the inside. So this equation, when I put the 3 up there, it got more narrow. It got skinnier. Okay. So what if I said, okay, well, what if we did this? What if we did f of x minus 2? Okay. Well, I would go right into here, and I can actually put that in x minus 2 in parentheses. What did it do? Well, let's see. It got more narrow, but it also shifted to the right. How much? 2. And I can look, it moved over 2. What if I said the same thing, but I make this a negative, and I say plus 1? Okay. So I put all these on here. So I just go right here. I'm going to say negative 3 minus 2x plus 1. Did I get on there? Oh, 1. All right, so there it is. So what all happened? Well, it reflected for one. It flipped. It got more narrow. It moved over to the right 2, but then it also moved up 1. 4 transformations. It reflected. It got more narrow. It moved to the right 2, and it went up 1. Now, how to do it without Desmos? Well, you have to remember what all is going on. Negatives reflect. Anything bigger than 1 is it's stretching and getting more narrow. If it's a fraction making my head hurt, that's where my graph gets wider. It compresses down. That's a fraction. X's lie. It says it's moving left negative 2, but I know it's moving right 2, and then on the end, that's your up and down, it moves up 1. All right, so that's transformations. And the last thing I want to do is, I believe it's systems. Remember a system, if you have an Xbox system, you have multiple things going on. So a system is where lines intersect. What is that point? Most lines intersect, actually all lines intersect, in one point, or the lines are parallel and there is no solution. They never intersect. And the other option is I could have a line and another line that's exactly the same line right on top of it. These intersect infinitely many times. Every single point, those two lines are the same. Okay, so when you're solving a system, you're figuring out where do the lines intersect. What's that one ordered pair where they cross, whatever it happens to be. Or are they parallel and never cross, or are they the same line and they cross every single time? And that is category 2.